friends, I am Mukund sir actually on behalf of Junavane classes. Today we are going to discuss one of the fundamental, I can say the concept of physics. It is obviously from standard 11 actually, but it can be extended into the standard 12 also. Similar concepts are there in the standard 12 also. So we are going to start with a basic, very fundamental chapter of physics, standard 11 obviously it is, and it is all known to us because in 10th standard we have same topic name as gravitation only. So some of the topics are extended in the standard 11. So we are going to discuss the concept of gravitation in more detail in this session, I can say, right? So you will come to know what is gravitation, what are the basic concept of gravitation, what is Newton's law, what are the Kepler's laws, what is acceleration due to gravity. All the topics or subtopics will be covered in this session in detailed manner obviously, and obviously you will come to know how to solve the numericals, what are the important formulas from this chapter, and how to solve the numericals, how should we go for the preparation of MCQs, and everything will be covered in details in this syllabus, in this session I can say, right? So let's start with the very basic fundamental topic, that is nothing but gravitation. Don't worry guys, friends, जर तुम्हाला वाटत असेल फिजिक्स इज व्हेरी टफ, इट इज नथिंग लाइक दॅट. जर तुम्हाला कन्सेप्ट कळले, इफ यू आर अवेअर ऑफ द कन्सेप्ट, you are grasping the concepts, then it is very much simple to solve the numericals which are based in the physics, I can say, right? So every topic is that much simple, but you should have the in-depth knowledge of that, otherwise it will be very difficult, right? So physics, I can say, it is a branch of maths in fact. So while solving the numericals, while solving the MCQs, you should require the basic knowledge of maths also. And that's why some of the topic in the standard 11 are based on the mathematics itself, right? Though the subject is physics, but some concepts are from maths because physics and maths goes hand in hand, right? So we'll start with very basic concept, that is nothing but gravitation. So stay tuned, write down whatever you want to note down, because I am going to have the session somewhat slower. Idea यायला पाहिजे because it is very much important topic. It is there in the CET also, it is there in the JEE and NEET also, right? So we'll start with some basic concept of the physics, that is nothing but gravitation. We'll have some basic look on the gravitation now, right? Okay guys, so come to the topic, gravitation. Obviously there are some scientists which you all know actually, Newton's, Kepler's, these are nothing but the scientists who have studied the gravitation in depth, and they have given some important principal phenomena to us. Those phenomena now we are going to discuss in detail, right? So gravitation, you see the diagrams, it is all about the masses and distance, right? So we are going to discuss one by one, concept by concept, don't worry about it. So very first topic from the gravitation is nothing but Newton's law of gravitation, right? So what is Newton's law of gravitation? What the law says actually? So according to Newton's law of gravitation, it is day-to-day life phenomena. आप सब लोग देखते हो, सुनते हो, you can experience also. तुम्हाला सर्व माहिती आहे, तेच concept इथे दिलेले आहेत, right? But you have to study those from mathematical expression point of view, from formulas point of view, and other things, right? So what is gravitation? For example, if I am going to release this pen, right? What will happen? Naturally, anyone can tell the answer. It is going to fall down, right? Why is it so? The basic or simplest answer is nothing but gravity, right? So everyone, obviously you are standard 11 student, you know the basic familiar we are with the familiar with the gravitation. What is gravity? What is the concept? Now we are going to discuss it in the very detailed manner, right? So what I can say that this object is attracted by the earth, right? So here there are two objects, one is nothing but this marker or pin, I can say, another is nothing but earth, right? So what is the conclusion? The conclusion says that every object in the universe, what I am saying, pay attention to it, every object in the universe is attracted by every other object, right? Now this is object, I am object, this board is also object, this bench is also object, you are object, there are number of objects in your surrounding, right? So according to Newton's law, every object in the universe is attracted by every other object. Means this marker, this pen will be attracted by the board, this pen will be attracted by the earth, this pen will be attracted by me, so on, right? So according to the Newton's law of gravitation, every object in the universe is attracted by every other object. Now in this phenomena, in this concept, we are just going to consider two objects. One is nothing but having mass m1, if you are going to see. Another object is nothing but having mass m2, right? So this is one object, this is another object. Now if I am going to say that the distance between these two objects is nothing but r, right? So I can say that if there are two objects having masses m1 and m2 which are situated at some finite distance r from each other, then whatever attractive force applied by B on A, similarly same force will be applied by A on object B, right? And the magnitude of that force, is always directly proportional to product of the masses. Now what do you mean by product? Product is nothing but the multiplication, right? So if I say very first statement is nothing but F is proportional to m1 multiplied by m2, right? Another statement says that, or another part of the statement says that this force is inversely proportional to r square. Now what is r? R is nothing but the distance between the two objects. So I can say that this force is inversely proportional to square of the distance between them, right? So combinedly I can say that what your force, that F is proportional to m1 multiplied by m2 divided by r square, right? Where m1 and m2 are nothing but the masses of the two objects and r is nothing but the distance between the two objects, right? So F is directly proportional to m1 multiplied by m2 and F is inversely proportional to r. Now if I want to replace this proportionality sign by equality sign, I have to put one constant. That is very basic concept in the maths, right? So I can write this term as F is equals to some constant g m1 m2 divided by r square, right? Where g is nothing but the universal gravitational constant. What g is called as universal gravitational constant. Now if I say if there are direct relation between two variables, if I say a is proportional to b, or I can write that a is equals to generally some constant k into b in general, right? कुठला constant घेतो आपण k, but in this case that constant is considered as capital G, and where capital G stands for the universal constant of gravitation, right? So I can say that what is the mathematical form of Newton's law of gravitation? F is equals to g m1 m2 divided by r square, where m1 is the mass of first particle, m2 is the mass of second particle, r is nothing but the distance between the two particles, and g here is nothing but the gravitational constant, which is called as the universal constant of gravitation, right? So this is the mathematical form of Newton's law of gravitation, and this is nothing but the statement of the Newton's law of gravitation. It says that every object in the universe attracts every other object with a finite force which is directly proportional to product of the masses and inversely proportional to square of distance between them, right? So this is all about the Newton's law of gravitation, how it looks like, so what is the mathematical form, what is G is called as, what is the value of G? Do you know that? In 10th standard you had heard about the value of G, where value of G is nothing but 6.67 into 10 raised to power minus 11 Newton meter square per kg square, right? This is the value of capital G, which never changes. If you go anywhere in the universe, the value of this constant capital G is always remains same, and that's why we want to call it the universal gravitational constant, right?